Lesson 50, natural selection. So this is going to be a big deal here, ladies and gents. This is the this is like the guiding principle behind evolution in nature is natural selection. So this is going to be a big deal to teach. I'm a little bit excited that I get to teach it to you first. That's another thing that I like being a teacher about, is that I always like teaching students for something for the first time. Remember way back in the day, I was teaching maths to year 8 students. I'm like, oh my God, I get to teach you about negative numbers for the first time. It's like, you guys will learn about negative numbers forever, but I get to be the first one. So I get to be the first person to teach you natural selection. So some of you guys may have learned it already somewhere else, but that doesn't matter. We will be able to describe how natural selection works. Let's go back and have a look and to see what we did last lesson. So last lesson we were talking about, I guess, the opposite of natural selection, which was artificial selection. So artificial selection is where the main point is we choose what gets planted. We choose how a species evolves. So we could evolve carrots to be orange and, big. Or you could think about it as like you could evolve it the other way. You could say, you know what, I want bluer carrots. I want really tiny blue carrots. We could have evolved them that way. But ultimately, the big thing we were evolving was we kept breeding the carrots that we wanted. And then we've already just talked about all these things. We talked about artificial insemination, which is where you're not copying exactly the same animal, but you're at least taking the semen or the genes of one animal and you're sort of copying it a little bit. Whereas cloning is exactly copying an organism that you want. And IVF is not copying, but it's at least sort of like narrowing the field. If you roll 10 dice and you go, you know what, I don't want the ones or the twos, I'm going to only keep the threes and the fours. That would be what artificial insemination is like. I mean, in vitro fertilization. Whew, IVF. We did some things. Why is this bad? Because ultimately it makes animals less unique. And as I said, if they're less unique and there's a change in the environment or the climate or a new disease, or if that original horse or animal had already prone to certain diseases or something, then it can affect everything in that particular population. But I guess what we're going to do now is we're going to talk about how does nature do it? What does nature do to deal with this? How does natural selection work? Because obviously evolution's been going on for hundreds of millions of years before humans showed up. So what is natural selection? Well, I think the best place to start is with a similar example to what we did before. We're going to take this desert here up in the top right hand corner. And what we're going to do, let me just grab a blue pen here. What we're going to do here is we're going to take this desert up here and we're going to put in some animals and we're going to see how those animals respond to different things in the environment. Okay, so what we're going to do is we're going to hatch two lizards here, and these two lizards are going to be part of generation number 1, the very first generation here. So what we're going to do, and one of them's really green and one of them's a little bit paler green, but so I've just decided to have a color spectrum here and a size spectrum here. Let's give them some names. Let's call this one down the bottom. Let's call this one, I don't know what, maybe we'll call this one Lena, and we'll call
Barry.
We'll call this one Tina, because easy. They're sisters, like living it up, and they're just going to explore this. They're going to explore this desert, and they're going to grow old together, and they're going to really, figure out. They're going to essentially be the brand new parents of this species. So Lena and Tina, they're just going to, figure out the world, and oh, crap. Okay, well, shit. All right, well, anyway, So Tina's going to go around and she's going to repopulate the earth here. And yeah, you might say, well, why Tina? Why was Tina better than Lena? Well, if you look at Lena, she was a brighter green. So if they were hanging out here, if they were hanging out in this desert, Lena would be a lot easier to see than Tina. Sure, Tina's pretty easy to see because she's light green, but maybe she could blend in with this cactus. But yeah, looks like Lena's gone. So, you know, yeah, it sucks, but you know, these things happen. Okay, so what could we then do? You know, well, let's say that Tina finds herself a nice, you know, boyfriend lizard, and then of course, you know, over the years they have some children, and then yeah, so we're going to jump ahead to generation 2. We'll go with generation 2. We've got, I don't know, two baby lizards. We'll go with, you know, whatever. And so yeah, and so these baby lizards, they go around and they you know, one of them is bigger than the other one. Is that going to make a difference? Who knows? But let's just say those lizards go, and then they go and they make a 3rd generation. Now, because of the 3rd generation, maybe we'll go with, like, let's say Leanne had 2 children, you know, we'll go with Alex, we'll go with whatever, Alethea, and then we'll go with, I don't know, and then of course we'll say there are 2 more, whereas there are 2 children up here. We've got Min, and we'll go with, I don't know, let's go with David. Actually, no, we won't go with David. We'll go with Samir. Why not? So these lizards here, now we've got a bigger population, you know, and because of this sort of bigger population here, right? We can have more children, and of course, the argument would be to say, well, because they're bigger lizards as well, they're going to make more. And of course, we can see again here the same sort of thing that I'm talking about. We're talking about a variation, right? They're not all the same color. We've got some light green ones. Oh, well, yeah, again. All right, so we've got some light green ones. We've got some dark green ones. You know, we've even got now a yellow one. So yeah, it's okay. Yeah. Again, we've got an issue where these bright colored big lizards are going to be quite easy to see. But you notice the smaller lizards and the lighter lizards are going to have a better chance of living. So it looks like Samir and Alethea, they're going to go off and they're going to find boyfriends and girlfriends, and they're going to make their own families. And so you can see here that poor Alex, she may have wanted to go and have her own children, but now she gets eaten. And because she gets eaten, her genes, her bright green genes, don't get added to the gene pool. Because Alex gets eaten, those genes disappear. Because Min gets eaten, his genes disappear. But Alethea also has those genes, so they're not completely lost. Samir has brand new genes, so he can add those brand new genes to the gene pool. So let's look at the next generation here. We've got a brand new generation. We're going to go with, let's stick with, we've got like 3 brand new lizards, as you can see here. The Alethea's genes have been passed down maybe through a couple of generations, and they end up in Talik, so he's still a bright green. But we can see, obviously Samir's genes are sort of, this yellow genes are being passed around, and maybe this Kevin lizard, maybe he's just a random mutation, like maybe a random mutation of the Samir genes, just smaller, who knows? But that's generation 4. Let's fast forward. Oh, okay. Well, you know, again, yeah, this happened. You know, now there's not as many bright green lizards, so I guess it's easy to see a green lizard if there's no more lizards around. So I guess, yeah, looks like Port Talik, you know, we lose another brave soul in this experiment. Now we've got another generation here. We've got an even brighter orange colored lizard. So what are we going to call this one? And then we'll go with, I don't know, who else have we got? We're running out of students, ladies and gentlemen. We're struggling here. Well, we've got, I guess we'll have to go with Uriella. We'll have to go with who else have we got? Have we got anyone left? We've got Matt. I forgot about Matt. Make Matt. We'll make Matt the big boss lizard.
He's gonna die because he's big.
This is the first evidence of like a huge lizard, and so that's kind of really good for him. And then maybe, yeah, I think we're pretty much out of people, so we're gonna have to start getting inventive. So yeah, we'll go with Bob down the bottom here. Why not? And so let's have a look what happens here. So what's gonna happen is, are any of these lizards gonna get eaten? Well, no, but Bob dies.
Why did Bob die?
You might be like, why did Bob die? Bob didn't even get eaten. Well, if you look at this, Bob is a very, very small lizard, so he's probably going to have a little bit of a short lifespan compared to Matt and Uriella, which are a lot older. So because Bob is small, he's probably not going to have a chance to reproduce, unlike these other guys. So yeah, I guess, you know, it's too bad for poor little Bob. You know, we lost another brave soul. Let's jump ahead to generation 6 and see what happens here. Whoa, look at that. This is interesting. Looks like Matt got busy and actually had 2
I'm a bit concerning too. What is going on?
Let's call these, I mean, he's got 2 lizards, so we'll go with Brendan and Brendan because they're the same color, so that makes sense. And then we've got a bunch of, you know, other lizards. We'll go with Alice, Brian, Cameron, and Daniel, and then we'll go with, like, I don't know, like Steve. Steve the lizard sounds cool. And again, like, you might be, this is actually a really important idea here that I want to bring up here. Uriella has had, you know, a child, probably Alice. And you might say to yourself, or her offspring is Alice. You might say, but sir, that's a green lizard. You might say, this is a step, isn't this a step backwards? Like, surely we should just go in one direction. But remember, mutations are random. They can be in any order. So you don't necessarily always step forward. Sometimes you may step backwards. You may have animals that, you know, it looks like they're evolving bigger teeth, and then you'll have one animal that has a smaller tooth. That's just a random mutation. That doesn't mean that Alice will survive. It might mean that she will, and this is also a good thing too. If suddenly the desert got really, really a lot of rainfall and started to make more grass, then suddenly Alice's disadvantage would turn into an advantage. So then she would go on to have more children. So it's not necessarily a step backwards. It could be, it just depends. But that's how nature does things. It just randomly throws the dice, and we'll see. Maybe the green color will help her. Maybe the green color will hinder her. If you look at Daniel on the other end of the spectrum, this is another random mutation. In this case, it's given him an even brighter orange color. Maybe this will help him. Maybe this will hinder him. Not sure. Oh, poor Alice. Looks like Alice gets eaten. And yeah, so let's see what happens in Generation 7. Generation 7, now I'm going to stop naming them because, god damn it, there are way too. Actually, we've got to name the only people that I haven't named yet. We've got to do one more. We've got to go David and David because they're the only 2 that haven't been named yet. Actually, I should, yeah. So we've got David and David, and we've got a bunch of other animals here. And we can see now that the big ones are able to reproduce more. The big ones are able to have more children. So that could be an advantage for them. We're still seeing some random green ones. We're seeing some random orange ones and a brand new random little one. But, you know, oh man, okay. And the little one died because, you know, it was too small to survive and it didn't have children before it died. So, yeah, it's a bit of a shame, but you can see the next generation. You can see now that these, the yellow ones seem pretty good. We've got a fair few options. We've got this brand new brown one here showing up. And again, these are random mutations. None of these are, and you will see sometimes that the evolution will take a step backwards, sometimes it'll step forwards. It's completely random. In this case, let's see. Oh no. Okay. All right. Oh man. Let's see. So, oh, what the heck's going on here? Maybe with the increase in lizard population, the bird population is allowed to evolve and grow, and you're able to have more birds. But luckily for us, we're only looking at one population here. But yeah, when you start looking at an ecosystem, you've got to really pay attention to what kinds of, you know, what the increase in one type of animal because of evolution may cause another type of animal to want to evolve so that it can take advantage of that. So that could be actually a case going on here. This dark brown lizard, you can see it's not going to have its new dark brown genes added to the gene pool because it got eaten. And why did it get eaten? Probably because it shows up on the sand. Because even now evolution's trying to go too far. But that's the advantage. Because this animal gets eaten, it can't pass its genes on to the next generation. So therefore, the next generation can only have genes in this gene pool, these kinds of colors. Sure, there might be one or two random lizards that randomly get born with mutations, but these are going to be the main ones. Let's fast forward to generation 9, and now we can see that this seems to be a good. This seems to be a growing population. We already have 4 lizards here, and those 4 lizards might go on to make 8 lizards, and then, you know, 16 and so on and so forth, because that type of generation has an adaptation. They have adapted to the land because of evolution. They have grown in size, which has allowed them to be able to have more children. And they've also changed their color to make them harder to be hunted by birds because, of course, they blend in to this soil color. And that's actually pretty much all of evolution, all of natural selection, in just me showing you what's happening here. And you guys can see as well that, yeah, sure, sometimes evolution will randomly try something new. And if this lizard survives, maybe that will form a new type of species. That might form a new type of species. It'll be new genes that get added to the gene pool, assuming that lizard survives. This lizard here is also it's just something new. It's a different type of mutation. And that's what I'm trying to explain here. A new sort of idea is the mutations are random. It's like you will usually you'll keep getting a lot more of these orange lizards, but every so often you get one of these grand lizards and they might survive and add their genes to the gene pool, or they may die and they won't add their genes to the gene pool, and therefore you'll just keep getting orange lizards. These random lizards are really important for if there is a change. Again, if suddenly the ground got a lot browner, then suddenly these lizards would have more and more of those and less of these. But that's pretty much how evolution works in a bit of a nutshell. Okay. Well, I guess that one's definitely not getting its genes added to the gene pool. But, you know, such is life. So, again, it just further confirms that we're going to have more and more and more of these darker orange colored lizards. And then maybe one day there will be, you know, maybe in a couple of generations, one of these darker colored lizards will survive because there'll be a change in environment. So that brings us to this idea of natural selection. Natural selection, I'd like you to copy this down here, ladies and gents. And this is trying to summarize what we did here. Natural selection is when nature selects certain individuals to survive and pass on their genes, thus changing the species over time. That's how natural selection works, and that's how this links to changing a species over time. That's code for evolution. This is sometimes known as survival of the fittest. Now, when we say survival of the fittest, we don't mean, you know, the most buff person, the person with the biggest muscles, the lizard with the strongest athletic, you know, is going to survive. We mean the animal that fits the system properly is the one that survives. If you've got a really cold environment, the animal with the most fur will probably be the one that survives. If you've got an environment where there are a lot of predators, the animal that can hide is the animal that survives. If you've got an environment where there are lots of other animals, the animal that can hunt and get food is the animal that survives. And of course, guys, this doesn't just apply for animals, it also applies for plants too. The plant that grows really, really tall, really quickly so it can get access to the sun is going to outlive the plants that, you know, don't grow very quickly. And so then that plant can make seeds and then it can continue. So what causes evolution? This is the key to evolution, but it relies on three things. It relies on variation, selection, and competition. Variation being that you need to make sure that you're making children, they're a little bit different than you. You know, maybe they're a darker color orange, maybe they're a lighter, maybe they're a different color green. Maybe your children are bigger than you, maybe your children are smaller than you. You have to have a variation. You can't just keep making children that are exact copies of you, because otherwise you can't evolve, you can't deal with what nature throws at you. Selection. What are the things that cause these animals, some animals to win and some animals to lose? What are the things that cause this selection? And the last one is competition. And the last question here is, what is it about this type of, what is competition like? How does different animals fight against each other? So, what I'm going to get you guys to do, you know what, I think what's best for us to do is this. I'm actually going to save the rest of these natural selection slides for next Wednesday. I think we've done a pretty good job today discussing discussing natural selection and giving you guys a bit of an overview this period of what natural selection is.